Hi again. So yesterday I started implementing clause database reduction and got as far as implementing a very naive way of doing this, which whenever it's triggered discards all learned clauses. And that's enough to test that the database management for deleting clauses works, but this is not the strategy we actually want to use. So the next thing to do is to implement a better strategy, and for that we need to compute glue levels for clauses. In the meantime, since the end of the last stream, I did a bit of cleanup, and I also implemented this bit field macro because I wasn't happy with the crate I was using before and the other crates that are out there that all do something that's not quite what I want. And with the using the syn crate and the parsing infrastructure of it, it's not too hard to implement such a macro. This was actually something when I first started writing proc macros, I completely missed that you can reuse the parsing infrastructure that it uses to parse Rust code to define custom syntax. And that made writing macros a lot more complex, but yeah. So this doesn't do anything too interesting. It just generates setter and getter functions that do the masking. And what this allows me to do now is, or one thing that this does that other crates don't do as far as I can tell, is that I can say, what did I call it? I think clamp. Yeah, that I can say I want a 6-bit field that's clamped, and that is going to be the glue. And I can specify the type that's used for the getter and setters independent of the bit size of the bit field. Okay, so this is the glue level of the clause, and this is also called neutral block distance. This allows us to store it, but we still have to compute it. And this is going to happen as part of the conflict analysis where we learn a new clause. That's the first time where we compute the glue, and then but I'm going to add that separately, or after this works. We will also update the glue level when a clause is part of a conflict. So if an existing clause is part of a conflict. So another thing is that we don't need glue levels for irredundant clauses. So we're only using it to rank the redundant clauses. I wonder what how the glue level is initialized when adding techniques that detect that certain irredundant clauses are actually redundant. So techniques that unsend this bit, they would also have to initialize this to some useful value. That's something I need to look into at some point. But that's not relevant now. So what is a good place to do this? And what did I do last time I implemented this? Okay, I computed this before I actually add the clause, which makes sense because I can do that, and then I don't add the clause and then change the value. And this also means that that I could have this as parameter. The question is, if I have a bunch of parameters, I don't want to have a bunch of parameters just identified by their order. And but it might be a good idea to require that all the things that are needed for a learned clause are actually initialized. So, but I'm not sure how much that actually will be in the end. I think for now I'm going to just do this set this at this point individually. So this would be the place where we compute this. So now the question is, I need some temporary array that I don't want to reallocate every time I do this. So I could keep this in here, but I also want to compute it on the literals in here, but also on literals that are part of the clause database. So to keep the borrow checker happy, I guess I have to pass the temporary buffer to the function that computes the glue. And I think I'm also going to add it to a separate module. Mm-hmm. I guess it's just a single function. And it needs to have a reference to the trail because that's where we store the decision levels. And I don't think I mentioned it this stream so far, but last time. So the glue level is just the number of different decision levels for the variables that occur in a clause. So we have the trail. We have the literals as slice. And we also have the buffer. I'm actually thinking of maybe doing it, maybe having a struct that contains the buffer and having that as a method of that, which would make the invocation of that a bit nicer. But then again, I'm not sure if at some point I might want to reuse the same temporary buffer for different things, as long as I know that they don't happen concurrently. I'm going to keep this simple for now. On one hand, I spent a lot of time thinking about stuff like this because that was something where I wasn't happy with how the structure of my previous attempts turned out. But on the other hand, it's difficult to do it right the first time. So what I try to do is think a bit about this so that I don't do something that turns out to be very hard to change later on. Because that happened for the very first version of VariSat I wrote. And then to avoid that, in the second version, I used my partial reference crate, and now I hope I can do something that works without using hacks like that. So this needs to be a vector of booleans, and that's just lit. Or just a slice, because whatever stores the slice, the actual buffer behind that will keep track of the variable count anyway. Compute level of a so the temp argument must Mhm. Yeah, so the idea behind the temporary buffer is that we can use it to flag which literals we have seen already, which decision levels we have seen already. And so we have a large buffer, we set just a few values and then just reset a few values. So we want to make sure that it's always kept in an all false state when we're not currently using it. So we never have to completely initialize it, because that would take a lot longer than every single use of it. Now, I wonder so to reset it, we could iterate over the literal second time, or we could have yet another temporary buffer where we push the literals that, no, not the literals, the decision levels that we have seen. What did I do here? Here I did iterate over it twice, yeah. I think that's different from what KISSAT does. At least I think it's different from what Kadikal did. I haven't actually looked at what KISSAT does. Where does it do this? Dateline, clue, levels. Oops. Isn't this called somewhere? Levels. Huh. Not sure. I think this was easier to follow in Kadikal. But for now, I'm just going to do what I did last time. I'm not sure if it's the fastest thing, but it's probably not going to be significant anyway. Okay, so for each literal we get the step and then the decision level. And so we set the flag for that decision level to true, and when it wasn't already true, then we increment glue, and then second time we go over this, we reset it to false. And that needs a cast. So one thing I'm not quite sure about right now is whether this will do what I want. No, whether I can call it a place where I said I'm going to call it. That was somewhere in here. Yeah, that was here where it's the clause actually added. Because that's already after backtracking, but before adding the propagation for the learn clause. And that means the last, so the literal that will be propagated is not assigned. And this requires that the literal is assigned. I don't know what happened here. When is this called? After backtracking. Before adding the clause. But I think here level stays valid even after or well, it still contains the old value, while here I made sure that at least in debug builds, accessing a step on the trail that's not currently assigned will panic. And I'm not sure if I thought about that when I wrote the last version, or when I wrote this in VariSat, or whether I missed this and got lucky that it still does what I want. But I do know which literal will be the one that is not assigned, because it's the one I'm going to assign just after adding the clause. So I can just have the so if the derived clause has a new clause, and I know that the first literal is the one that is unassigned, and that's also the one that after assigning will have the same decision level as the highest decision level among the other literals. So I can just exclude it, and then it works and also makes clear that we are excluding that and not counting it as a separate decision level. That might be different from what other solvers do. I'm not sure. It's I remember that reading some descriptions of how this works that were a bit a bit unclear on what you should do. Where do I update this, the length of this? Date trail. Oh, right, this does not actually track the number of variables, but instead updates this on demand, I think. And that's okay. It's actually probably not bad, because then I don't need to make these as large as they would be if I always update them eagerly. So this is temporary decision level flags for Google computation. And this is going to take reference to the trail instead. No. And then it can also update the buffer for the Google level flags. And that should be one more than the decision level, I think. Yeah. Then I also need to update the comment, because that said it should be larger than the number of variables. And at least one more than the current decision level. Oh, I hope I wasn't writing too much code that was hidden behind the webcam view. I should probably put some markers on my monitor here and there, so I don't forget about that. Oh, what did I call this? Ooh. Ah. And okay, now this stores the glue level. So the first thing we can do is not delete clauses with a small enough glue level. What cutoff did I use last time? If the glue level is 2 or smaller, I'm going to keep it unconditionally. And again, I think this might correspond to glue level of 3 if you count this differently. So if the clause is not redundant, then you have to bail out anyway. If the glue is 2 or below, we're also going to keep it. Let's see if that makes a difference on a single random problem. Oops. And no debug output. I might want to add some not debug output, but basically just some stats line that is output every n conflicts or using a timer or something like that. So I think this got even slower now. But one thing to keep in mind is that even though this deletes some clauses, it never reclaims the space used because garbage collection is separate from this and not yet implemented. And so deleting some clauses still makes unit propagation faster, but not as fast as it would be if you also compact the buffer that stores the clauses. Because that improves locality of the data that's accessed. And what I also did in VariSat during garbage collection is rebuild the watch list, because that's essentially free performance-wise, and make sure that the next time unit propagation happens, the clauses are accessed in sequentially in memory order. And the watches are going to get permuted again after a while because unit propagation will move the watches around. But I think it helps a bit. I'm not sure if I ran experiments for that, but I think there was a blog post that Crypto Mini SAT did have some changes that to ensure that the watch lists are from time to time ordered in sequential memory order. Okay, so it did help. So it is an improvement. I just forgot how much slower this got after aggressively deleting things. I wonder if it's still faster if we don't delete anything at all, or if I just mixed up the benchmarks. But again, this is just running benchmarks to see that stuff doesn't fail, and not to actually tune performance. It's just no point to doing performance tuning of this at this point. So yeah, this is still too aggressive. But I guess it's the first thing I could commit. Probably going to clean it up a bit later, but that's why I have a work in progress branch and a big warning on the repository that I'm going to force push things. So even if I want to clean up things that already landed in the main branch, I will still do that. So what did we do? We store the glue level. We have data for that. We update the size of that. We update the size of the buffer. We use the glue value to filter this, and we don't forget to add the file. So this is compute glues, and I want to say and use them during reduce, but that might imply that we use them in the way that they should be used, and we're not doing that yet. And start using them for reduce. Okay, so the idea is to keep clauses with very small glue level forever, and then for clauses with an intermediate glue level, so this so 6 or smaller was what I used here. Those are for those we keep them if we may if we recently used them. And that means we need to keep track of whether we used a clause. And using a clause means using them to derive another clause. At least that's what I did. Not sure if I ever checked if that matches what other solvers implement. I think I got this from the paper that introduced this 3-tier approach to clause reduction. So where would this be? We have clause, the header, used, and let's see if Visual Studio Code can find uses of used. Ooh, that doesn't, no. That did work. Mark clause is used. Huh. Okay, this logic is not what I expected. So in Varisat, I actually had the tier as part of the clause data. So each clause explicitly was part of the what do you call it? Core, mid, and local. And if a clause was part of mid and not used for a while, it got demoted to local. And I think local clauses, how did I clean them? Okay, I deleted half of the local clauses every time, I think. And for the one in the middle tier, I reset the active counter and moved inactive ones to the local tier. And that's what I had from the paper that introduced this. This I don't understand just from looking at it in isolation without seeing where everything is updated and checked in other places. But because I looked at the clause header here and didn't see a tier, I was thinking, oh, it's just doing this implicitly by looking at the glue level. And interestingly, it's using much more bits for the glue level. How many bits did I use? Yeah, I did use 6 bits in the past. Huh. So I think I might just improvise a bit for now, and then later run some experiments to see which things actually matter and which don't. And just, yeah, improvise. So I'm going to do what I thought Kissel was doing until I looked into this just so what I thought Kissel was doing at the point I started streaming today, which apparently is not what it's actually doing. So this might be a really bad idea. So this is a kind of nice thing that, jumping around a bit, this is a kind of nice thing of using the parsing infrastructure from the syncrate, that you can, without too much effort, associate warnings and errors of the generated code with parts of the things you parsed. So this generates a function that doesn't have a documentation because I didn't add any documentation as part of this attribute. And the warning for that gets placed at the place that was used to generate it. So let me actually open that. There's this quote span, and here's say bitfield span. That's the source span of this thing. I'm not sure why it doesn't cover all of this. Don't think it's a bug in my code. Also not sure if it's a bug or just a limitation of the way diagnostics and proc macros interact right now. But I'm basically, this bitfield span is it's just the thing that I pass. I say, give me the span of that, and then I say this code is generated from this, and the diagnostics get mapped. And if you manually pass token streams, this takes a lot more effort to get right. Anyway, used. I want to count how often a clause was used during conflict analysis. Okay, this is where that happens. This and this. So kind of want to add a bump clause function. And I think I cannot take self as parameter because that's going to get me into borrowing trouble. And this only really happens for long clauses. So what does this take? This takes we have long clauses. And clause reference. Anything else? Eventually, yes, because this should also update the glue level. But one thing at a time. So this is apparently something I made up because it's not what Kisset is doing. Unless it is, and I just didn't follow the logic correctly. This is what I'm going to try. And I still need to call this. Only if it's a long clause. Can I unify this? Because conflict is a conflict clause, it's binary or long. And on the trail, the thing is the reason. That can also be a unit clause or a decision. But I think I'm going to manually match the two places where I'm doing this. If at some point, I don't think I will do this in more places at any point. Then eventually I might add some other kind of constraints like exclusive OR clauses and stuff like that, but that would needs quite some changes all over the place anyway, and might even get completely separate conflict analysis if I want to do smart things there. But yeah, that's problems for the future. And for the reason. Okay. And for reduction, the idea was then to check if the clause was used. Or actually, if the glue is smaller, 6 or below, and if it was used, Does that make sense? Mm. So at some point I have to decrement the used counter. And I think I want to do that every time. I'm not sure how I'm going to clean the local clauses. The one where the glue level is higher than this. Because I was using the activity, which I don't maintain and don't want to maintain for that. Anyway, if it was used, I decrement that and keep the clause. If it was not used, this is the thing where previously I was demoting it to a higher level, but I don't have a way to do that here. To a higher tier level. I guess at some point I need to make sense of what Kissa does there. Even if whatever I do now happens to work, I do want to know what I'm doing differently if I'm doing something differently. Yeah, I guess otherwise I'm just going to. Oh, otherwise I can just consider it a local clause for this reduction. And if it's used again, it would be promoted back to the middle tier again, which is not what happened in Varisat. Yes, this could use a diagram for the basically state machine of the tiers and the transitions. I might at some point add an ASCII art one as a comment for this. Yeah. Anyway, otherwise it's going to be a candidate of a clause to remove. But it's just going to be candidate. I still have to collect them. Is this infrequent enough that I can allocate buffer for this? I guess. So we have the deletion candidates. And we're going to push the class reference. And at this point, the thing where I wrote the test for last time also isn't relevant anymore, because I'm not deleting them while iterating. But I didn't think of that back then, and it's still good to know. It's still good to have a test that kind of documents that deleting clauses during iteration is supported. So I don't. So at least notice if that's some invariant that has some invariant that I don't uphold anymore if I change the clause allocator, even if I'm not using it for now. It's so what do I want to do here? I not just the class reference. I also want to have some priority. And I saw that Kisset is using the glue and the size for this, and it's basically doing lexicographic sort on that. And I guess I will do the same thing. So the glue and length. And then there's a partition point. Yeah, that's the thing I want. I think no, that's by predicate. There's also partition by basically it's using quick select, I think. Partial sort. What was it called? Probably among the partition at index. Select nth unstable. Right. So and this allows us to just say we want to sort them by size, but not perform a full sort. So and then we can, at this point, actually delete the clause. And yeah, I guess. No, that's this needs some comments anyway. But I have to think about what good comments, what would be a good comment here. I certainly don't want to collapse this, because this is one logical thing. This is a saturating decrement, but it's also has flow control in here, so I cannot use the saturating decrement. Now this might already work and be an improvement. Let's see. Certainly faster. Okay, this and this also should only be this. And apparently not if they are empty, because this needs to return a reference to the actual element at that index. Yeah. "12 seconds, what was it before? 15 seconds, so again an improvement. What performance does CDCL get in plain mode? So this is not the wrapper I previously used. That it also disables reduction and a bunch of other things, but this just disables pre and in processing. So this has basically the full versions of what I implemented, even if I didn't implement the full version yet, and also garbage collection, which I didn't implement. And this has the switch between two modes, one that's tuned for satisfiable and one that's tuned for unsatisfiable instances. That was also something that I deactivated before. So quite a bit faster, but not orders of magnitude faster. Yeah, I think this is what I wanted to do for today. I will probably, in the meantime, have a look at what CDCL does in detail. That's something I find easier to do when I'm not streaming, because it's trying to understand code others wrote while being on stream is always feels a bit more stressful than doing that on my own. And what else? Yeah, garbage collection is something it's probably the next thing I'm going to add. Yeah, and adding some comments. So this is going to get a work in progress commit. Right, I added a. Isn't there some don't run? Yeah. Yeah, this one. And pushing this. That's it for today. So bye and see you next time.